Hi, my name is Semih Serkan USTAOİLLU. Today I will present to you a paper at the conference on the CD waste management model for the construction demolition of buildings, a case of Istanbul in Turkey, which we prepared with Associate Professor Dr. Sevgül (LİMONCU). CD waste is a type of solid waste product. It includes construction and construction site products contained within buildings and infrastructures that are generated as a result of activities such as construction rehabilitation, deconstruction demolition, and disaster works, and may also include other waste varieties. Throughout the overall lifespan of the buildings, most CD waste is generated during their construction demolition process, where the entire buildings becomes waste. For that reason, generated CD waste must be managed, for it has a negative effect on the environment by utilizing correct methods through various stages in an environmental conscious manner. However, existing CD waste management legal and administrative legislation remains far from adequate regarding the process of the deconstruction and demolition of buildings. In particular, due to intensified urban renewal efforts subsequent to the enactment of the law of transformation of areas under disaster risk May 212, significantly larger quantities of CD waste has been generated, and Turkey's burden of managing large quantities together with existing problems of CD waste management has risen. The lack of comprehensive CD waste management model appropriate to the conditions prevailing in Turkey, as well as the absence of the related legislation and relative indifference of public and private enterprises regarding CD waste, has resulted in generated wastes not being assessed properly, and the bulk of the such waste being destroyed at the CD waste storage yards. In this context, as a sustainable CD waste management method for the deconstruction demolition of buildings in Turkey, enabling a proper assessment of waste generated gains importance. In this study, CD waste management in Turkey building deconstruction demolition works are and implementations of CD waste management in those works have been analyzed. As the case study at location Istanbul Kadıköy district was selected, where the majority of urban renewal efforts in Turkey are concentrated. A survey evaluating the construction demolition process was conducted with 30 of the 45 firms undertaking the construction demolition work in the chosen for study. This study was conducted with the face-to-face interviews. It consists of 5 sections and 34 questions. Many countries have already established regulations, conducted scientific studies, and prepared roadmaps for CD waste management. As for Turkey, despite the control of regulation of the excavation soil, a construction and demolition waste law in effect, which is a general law solely regulating the control of the CD waste in regards to CD waste management. It remains insufficient considering prevailing conditions in Turkey. While CD waste management, CD waste related methods utilized in developed countries are assessed at levels reaching up to 90%, since CD waste management is not a method applied productively. Turkey waste is assessed with existing traditional methods shown in Table 1. Within the scope of this case study, and with a survey conducted with the reachable 30 of 45 excavation firms doing the construction demolition works in the Kadıköy district, the construction demolition works and CD waste management awareness during the construction demolition process have been identified. In the case study, the operations of the firms are given in Figure 1. When the Figure 2 of the survey study is examined, it is observed that only 3 firms from a total of 30 incorporate an architect within. The reason for low numbers architects employed in this field demonstrates the level of significance of architectural works in the construction demolition. Insufficiency of significance given to the architectural works causes CD waste not being properly managed. When the Figure 3 of the survey results is examined, given the ineffectiveness in the contents of the existing planning of the environmental prevention measures in Turkey, and additionally, since these measures were implemented by the firms merely to fulfill obligations, to the emerging results are not sensitive to the reality, but to the contrary, may even be said to pose a threat to the environment. When Figure 4, namely the survey results of the sections regarding demolition methods utilized by firms is examined, It is seen that manual demolition with impact, and demolition by high-reaching excavator methods frequently used, as well as demolition using grapples and shears. While manual demolition is a positive method for recycling CD waste, other methods have a negative effect. Generally, stairs and facades are not deconstructed, while roofs and wood products are often deconstructed. Consequently, CD wastes first and foremost should be managed without causing a health risk, environmental safety. A CD waste management methodology appropriate to the conditions prevailing in Turkey should be developed for CD waste produced in large quantities as a result of deconstruction demolition works, especially given the recent increase due to the numerous factors. CD waste management during the deconstruction demolition of buildings is approached in three stages: pre-application, post-deconstruction demolition stage. Pre-deconstruction demolition stage, deconstruction demolition decision, determining the contractor and teams, environmental impact and surrounding analysis, building analysis, CD waste management planning, planning and scheduling, deconstruction demolition permit, deconstruction demolition building, processing CD waste storage, transportation of CD waste, cleaning the worksite. The building analysis is structural system analysis. In the structural system evaluation process of the building, the type of structural system, whether it damaged or not during any previous disaster, if the structural system has any association to neighboring buildings, whether there are damage and or deformation on the columns, foundation, flooring, or beams, integrity of the system, current conditions of the walls, structural system elements to be used in the construction demolition methods should be decided and evaluated. Architectural evaluation, this action step should be evaluated with works such as for buildings without construction plans, manifestation of the current situation of the building by redrawing plans from statistical service showing their original state. For building with construction plans, comparison with the current state of the building and historical identification of the change. Spatial analysis performance, determining of work areas which might be risky for the workers. Specification of the building, whether it has historical or monumental value or not. Classification or CD waste particles which might fall or fly uncomfortably during the construction demolition work, detection of the possible dust, noise, and vibration conditions. Source reduction, prevention, assessment methods, source reduction, prevention, reuse, recycle, disposal. The construction demolition, application of the construction demolition stage, the construction demolition permission process, the construction demolition works of a building, processing CD waste, storage of CD waste. Preparation of the post-deconstruction demolition stage, preparation for this assessment, to clean the arrange of work site, to store reusable building products, the conversion of the site into the green area if the building products are not used. Conclusion. It is necessary to manage CD waste in order to reduce amount of raw materials and energy used producing new building and building products, to avoid negative impact of the hazardous material used in the past, and to retain control over them without negatively impacting the environment. For the CD waste to be managed, it's also crucial to manage process where CD waste is generated in the construction demolition of buildings. With these suggestions, it is considered that the impact of the CD waste from the works on the close vicinity of the building and the broader environment will be minimized. Appropriate solution will be developed by accurately determining the magnitude of work. Appropriate deconstruction or demolition methods will be utilized by taking CD waste into consideration. Significantly, high quantities of CD waste will be recycled. New raw materials used and energy consumption required in product new building materials will be reduced to minimum levels. The amount of CD waste storage underground and destroyed will be decreased. Works will be conducted and under more controlled and safer conditions. Thank you for listening to us.